For today's MCAS topic, we're going to be going over a number of different algebra topics as well as talking about functions. So we're going to first start off by talking about solving equations. So when we're solving equations, you always want to work backwards to solve for the variable. Another way to think about this is we're always going to be doing operations to undo things until we're able to get the variable by itself. All right, here's our first example. In the equation below, t represents the time t in hours it will take a delivery driver to complete a 350-mile trip. So it says 150 plus 50t equals 350. What is t, the time in hours it will take the delivery driver to complete the trip? Okay, so really we're just solving for t here. So we are solving this equation that's given to us and getting t by itself. So we can start off by subtracting 150 from both sides. And that way we're undoing this 150 that's being added to the left-hand side. So that leaves us with 50t equals 200. And now again, we want to undo the operation next to the t. So right now it's 50 times t. So to undo the multiplication, we're going to divide both sides by 50. After dividing both sides by 50, that leaves us with t equals 4. So the time t in hours it will take the delivery driver to complete the trip is going to be 4. So that looks like our answer is B. All right, next we're going to talk about solving and graphing inequalities. So when you are solving inequalities, you're going to solve them the same way as you would when you're solving an equation. There is one exception, which is if you multiply or divide by a negative number, then you have to flip the inequality sign. So if originally the inequality is a less than, you have to change it to a greater than. If it was originally greater than or equal to, change it to less than or equal to. Now, when you go about graphing inequalities, a couple of reminders. If you have either x is less than or x is greater than a number, you're going to graph this using an open circle, and you're going to shade in the direction of the arrow. So for x is less than, we would shade to the left. For x is greater than, we would shade to the right. Now, if your inequality is less than or equal to or greater than or equal to, this is where you're going to use a closed circle. And again, you'll shade in the direction of the arrow. So if it's less than or equal to, you'll shade to the left. If it's greater than or equal to, you'll shade to the right. All right, let's take a look at example 2. Which of the following graphs represents the solution of the inequality below? So we have 5 is greater than or equal to 2x minus 3. So let's go ahead and take this inequality and get x by itself. So it looks like we'll start off by adding 3 to both sides. That's going to leave us with 8 on the left, so 8 is greater than or equal to 2x. We want to get the x by itself, so we'll divide both sides by 2. That's going to leave us with 4 on the left and x on the right. Now you'll notice that the way that I had written things on the first slide, we always had x on the left-hand side. So I'm going to rewrite this so that x is on the left. Now when I do that, I'm not changing the inequality, but I do need to rewrite it so that the inequality is pointing towards the x, because the x is what's being pointed at the way that it's currently written. So x is less than or equal to 4. Now let's take a look at the graphs that we have here. So first we know it's less than or equal to, so these all have to be closed circles, which they all are. And the closed circle should be on 4. So it looks like we can narrow it down to either A or B. And since we have x is less than or equal to 4, that means we would shade everything to the left of 4. So that looks like our answer is going to be A. All right, the next thing we're going to talk about is evaluating equations. So when we say evaluating, really what we mean is you are going to plug in a given value into an expression or into an equation that's given to you. After you've plugged it in, then you'll follow your regular order of operations and simplify until you get an answer. All right, take a look at example 3. Melinda invested $1,000 in a retirement account. The formula below shows the amount of money A that will be in her account at the end of T years. Now, it's really important for these problems that you understand what everything is supposed to represent. So we'll keep that in mind. So we already know A represents the amount of money that will be in the account, and T represents the number of years. All right, let's keep reading. In the formula, R is the interest rate expressed as a decimal. Melinda's account has an interest rate of 6%. Which of the following is closest to the amount that will be in Melinda's account at the end of 2 years? Okay, so R represents the interest rate, and it says it's expressed as a decimal. So we're told the interest rate is 6%. We're going to write that as a decimal. So moving the decimal place 2 places to the left, that leaves us with 0.06. We're also told that the amount of time T that has passed is 2 years. So we're going to go ahead and evaluate this expression by plugging in 0.06 for R and 2 for T. All right, now we follow order of operations. So inside the parentheses, we'll go ahead and add that together. So that's 1.06. Next, we deal with the exponents. So we're going to square 1.06. And then we can multiply by 1,000. And that's going to be 1,123.6. Now the question actually asked us which of the following is closest to the amount that will be in Melinda's account at the end of 2 years. So it looks like $1,124 is going to be our closest amount. All right, the last thing we're going to talk about are systems of equations. So in a system of equations, you want to first start off by determining what the 2 unknowns are. After you've determined what those 2 unknowns are that you're going to solve for, you're going to write a system of equations that represents the information given. Now, generally for systems of equations that we're going to do, that usually means 2 equations that you're going to write to represent this information. Once you've written the system of equations, then you can solve that system, and there are a number of ways to solve a system of equations. Some might be easier than other methods. So we can solve a system by graphing, by substitution, or elimination. All right, let's take a look at an example. The only coins that Alexis has are dimes and quarters. Her coins have a total value of $5.80. She has a total of 40 coins. Write a system of equations that represents this information and determine the number of dimes D and the number of quarters Q that Alexis has. All right, in this problem, it actually has already very much defined the 2 unknowns for you. So the 2 unknowns being the number of dimes D and the number of quarters Q. So let's go ahead and write our system of equations using the information that's given. So let's use the information first that she has a total of 40 coins. We know that the coins that she has are just dimes and quarters, no nickels, no pennies. So that means however many dimes she has D plus however many quarters she has Q should sum up to 40. So that means I can write the equation D plus Q equals 40. Now the second piece of information that I have is the total value of her coins. Now we know that dimes are each worth 10 cents and quarters are each worth 25 cents. I'm going to write this second equation in terms of cents, so we don't have to deal with the decimals. So if each dime is worth 10 cents, so if I do 10 times D, that will give me the total number of cents coming from the dimes, and 25Q, that will give me the total number of cents coming from the quarters. Added together, that should total 580 cents, right? $5.80 is 580 cents. So I can write my second equation, 10D plus 25Q equals 580. Now we have a number of different methods to go about trying to solve this system of equations. You can try to solve it by graphing, by using substitution, or elimination. Now in this particular case, because I can get one of those variables, D or Q, by itself pretty easily in that first equation, I'm going to opt to use substitution. So that means I'm going to take that first equation and I'm going to solve for one of those variables. So let's say I solve for D, get D by itself. I'm going to subtract Q from both sides, so that leaves me with 40 minus Q. Now comes the substituting portion. I'm going to take this 40 minus Q and I'm going to substitute it into the second equation where I see D. So instead of 10 times D, I'm going to have 10 parentheses 40 minus Q. And then I write the rest of the equation. You'll see now that this leaves us with just one variable in this equation, so we'll be able to solve it. So we'll distribute the 10. That leaves us with 400 minus 10Q plus 25Q equals 580. We'll combine the terms that have Q in them together, so that's 400 plus 15Q equals 580. And then we'll subtract 400 from both sides. So we have 15Q equals 180, and divide both sides by 15. That leaves us with Q equals 12. And now that tells us the number of quarters, but we still need to figure out the number of dimes. So what we can do now is we can take this Q equals 12 and plug it back in to that first equation, because I know D is equal to 40 minus Q. So 40 minus 12 will give me the number of dimes, and that comes out to be 28. So in total, Alexis has 12 quarters and 28 dimes.